Review Chapter 4. This is going to be the first half of our Chapter 4. We'll do 4.1 through 4.3. So let's get started. 4.1 was congruent figures, and we said that the definition of congruent polygons is that all corresponding sides and all corresponding angles are congruent. So let's write that down. The definition of congruent polygons is all corresponding sides and all corresponding angles are congruent. And in our problem here, we're given a congruent statement. We are told that triangle SAT is congruent to triangle GRE. So the first thing I'm going to do is mark my congruent sides and angles. So I use my congruent statement. My first side is SA, is congruent to my first side, which is GR. And then I do AT, is congruent to RE. And from T back to S is congruent from E back to G. There are my congruent sides. And now let's do our angles. And I am going to use different colors here. We know that angle S is congruent to angle G. They are in first position. And then we have angle A is congruent to angle R. Those are in second position. And angle T is congruent to angle E because they are in third position. So now let's look at our angles. So who is angle S congruent to? Well, we could simply use our congruent statement, or we can look at our triangles. We know that angle S and angle G are in the same position, and segment GR, let's go find segment GR. That's our one mark, and we know if we look at our congruent statement, it's position 1 to 2, or we can look at our triangles. We go from the blue angle to the orange angle, so that would be side SA. You can use either your congruent statement or your marked triangles. All right, let's do next one. Angle E is congruent to angle T. Side AT is congruent to, well, it's our blue side here, and we go yellow to pink. So segment RE. And again, we can use our congruent statement up here. Look, AT goes position 2 to 3, so we go 2 to 3, which is RE. And now we have triangles. Triangle ERG is congruent to who? Well, how did we get there? Pink, orange, blue. So that's triangle pink, orange, blue, TAS. And the next one is segment EG is our green one. So EG is the position 3 back to 1, so that's segment TS. If we look on our triangles, E to G goes pink to blue, so we go pink to blue, T to S. And triangle REG starts at orange, pink, blue. So let's go triangle orange, pink, blue. Triangle ATS. And finally, angle R is the same as angle A. So you can use your congruent statement or sometimes marked triangles. Marked figures are the easiest, especially if you're working with colors. Color is good. All right. So that was section 4.1. 4.2 and 4.3 were where we got our 4 triangle congruents, 3 postulates, and 1 theorem. The kind of weird one out here, angle, angle, side, is our theorem. And what are we asked to do? Can we prove the triangle's congruent? If so, write a congruence statement and name the postulate you would use. If not, write not possible and tell what other information you would need. Okay, let's look at our first set of triangles here. Well, on my first triangle, I have 2 angles and included side. On the second one, I have 2 angles and an included side. So that means I'm going to be able to use the angle, side, angle postulate. And let's write our congruence statement. Remember, if you make good choices on the first one, the second one is easy. So I am going to go angle 1 across my side to angle 2. So that's y, t, n is congruent to triangle, start at 1, go across my side to angle 2, WSJ. Yay! Let's look at our next one. All right, can I make these triangles congruent? Well, I have one side and one angle on each. Can I get something more? I certainly can. I can use the reflexive property of congruence to get that side. And now I have side, angle, side postulate. And now how am I going to write my congruence statement? Well, I think I'm going to go across side 1 to my angle and then down side 2. So that would mean I would go triangle EAL is congruent to, now I need to go side 1 to my angle to side 2. So that's triangle PLA. Yay! All right, let's look at the next one. I have 2 congruent sides on each, and our good friend, the reflexive property of congruence, lets us get that third side, which means we can use the side, side, side postulate. And now we need a congruence statement. So how am I going to do my first side? I think I'm going to go across side 1 and then across side 2. And then back down side 3. So that would be CNA is congruent to triangle. Now let's figure it out. Side 1, side 2 would be AOC. So that was good. All right, let's look at our last one here. We have one set of congruent angles. What else can we do? Well, we can get a side there by the reflexive property of congruence. But is that enough? This one is not possible. So what would we need if we were going to make these triangles congruent? Well, we have a number of options. We could do this side and this side. We would need 2 on that. And do side, angle, side. Or we could use these 2 angles and do angle, side, angle. Or we could use these angles and do angle, angle, side. So we have lots of options for that. I think the easiest one, my favorite, would be to just make side PA congruent to side. Which direction would that go? I went to my angle, so RL, and then I would be able to use side, angle, side postulate. Again, geometry, we have 27 different answers for the same problem. So those were okay. What's next? Oh, a proof. Yay! Who doesn't like proofs? I don't hear anyone out there saying they don't like proofs. All right, well, let's define explore this. Let's see what we can do. First thing I see here, just looking at my diagram, is reflexive property. So I am just going to redraw my triangles here, just so that they're easy to see. This is AA, CC, D, B. Okay, and I am going to put in the reflexive property. So I know that I have a side using the reflexive property. Okay, what else? Well, I don't see anything else on there, but let's look at what we are given. We are told that AC is perpendicular. Perpendicular means right angle, right? So I have that, so I can come down here and mark that. And so I know that I'm going to be able to get an angle using the definition of perpendicular, and then I'm going to have right angles, and right angles are congruent. So I am going to be able to make these two angles congruent, not only right angles, but they're congruent because both of them are right angles. So I now have congruent angles. And what else are we told? Well, let's see. We are told that C is the midpoint. Midpoint means I've got two congruent segments. C, there's point C, is the midpoint of who? Segment BD. So that means that I can mark these two segments congruent. Right? So now I've got another side here, and by definition a midpoint, right? And this looks to me like I am going to be able to use the side angle side postulate. So when I write my proof, I am going to make sure I have a side and an angle and a side. I'll spread these out a little bit. And an angle and a side, and then I'll be able to make my triangles congruent. So how did I get my first side? Well, the first thing that I did was I said that segment AC is congruent to segment AC, and that's by the reflexive property of congruence. Okay, then how did I get my angle? Well, I was told that segment AC is perpendicular to segment BD, and that was given to me. Now, what did that let me do? That let me say that angle ACD and angle ACB are right angles. That's the definition of perpendicular. And then what did that let me do? That let me say that angle ACD is congruent to angle ACB because we know that all right angles are congruent. All right, and then how did I get my last side here? Well, I was given that C is the midpoint of segment BD. That was a given. And what did that let me do? That let me say that segment BC is congruent to segment DC. And that is just definition of midpoint. And now I want to write my triangle congruence. So I'm asked to prove right here that triangle ABC is congruent to triangle ADC. Now, is that true? ABC, ADC. Yes, it is, by the side angle side postulate. So this is why we separate out our given and we do one piece at a time. I define, explore, see what I have, and then put everything I have together. All right, and we have one more proof. Whee! And our review will be done. That won't be too bad. All right. First thing I see here, I don't even know what I'm looking for. I've got a reflexive property here. I can get a side using the reflexive property. I'm going to move that some. I can get a side, and I don't want to put it there because I want to use that. I can get a side using the reflexive property. Okay, well, that's about all I see on the diagram. Let's look over here. What are we given? That segment RU is parallel to ST. Okay, and segment RU is perpendicular to UT. So let's draw that in. And, well, what's up here at the parallel? I'm thinking alternate interior angles. Perpendicular, I'm thinking right angles, right? So we've got a right angle there, and we are told that segment ST is perpendicular to RS. So there is another right angle right there. So I am going to redraw my triangles and separate them out here. And this is R, U, T. This is T, S, R. And we know that we have this side by reflexive. And we know, let's make these blue. We know that these are right angles. So I am going to be able to get angles by definition of perpendicular, and right angles are congruent. So these will be congruent down here. And what else can I do? Well, I need another angle or another side, but I think I can get another angle because I've got these parallel lines. So let's look at our parallel lines, right? And we know that our parallel lines are cut by this transversal right here. And we know we have alternate interior angles. So I like to just kind of dot in my figure here. Which of those angles are going to be useful to us? Well, I believe it's going to be this angle right here and this angle right here. No, those are not the alternate interior angles. Do you see that they're not touching our lines properly? So let's go back. Let's find which angle we want. Oh, this one might be it. How about that right there? And how about that right there? Are those in our triangles and alternate interior angles? Yes, they are. So let's find them here and here on our diagram. So let's mark down here those angles right there. So I'm going to get another angle, and that's going to be using my alternate interior angles theorem. And can I make these triangles congruent? Well, you know what? This sure looks to me like the angle side theorem. So let's look at this to write a proof. We need an angle and a side. We might want to spread these out a little bit. And then our triangle congruence, which should be a side. Okay, well, how did we get our first angle? Well, that is our, it doesn't matter which one we use, let's do the perpendicular. We are told that segment RU is perpendicular to segment UT, and segment ST is perpendicular to segment RS. That's a given. That was given to us. And then what did that let us do? That let us make angle U and angle S are right angles. That's definition of perpendicular. And then what did that let us do? That lets us make angle U is congruent to angle S because we know that all right angles are congruent. So we needed 3 steps to get that first angle. Now how did we get our second angle? Well, it's the pink ones here. And what let us do that? We were told that segment RU is parallel to segment ST. That was a given. And then what did we do? We could say that angle URT is congruent to angle. Now, how did we get that? I started at my right angle and went up. So STR, how come? My alternate interior angle theorem. Okay, so now I have 2 angles. How did I get my side? Well, the side was the easy one, but be careful how you name it here. I'm going to name side RT is congruent to, is RT congruent to RT? Look, on my left triangle here, I go from my pink angle down. So this one I have to go from my pink angle up. I have to start at my pink angle and go to my blank angle. So that's going to be TR, because it has to be in the right order. And that's just the reflexive property of congruence. Right? So now I can say that my triangles are congruent. How come my triangles are congruent? Well, let's see. I can say triangle URT is congruent to triangle STR. This is what we're asked to do on our proof here. Can I say this? URT, okay, I went right angle to pink angle and around. STR, yep, that works. And that's the angle side. And this one's the funny one. So it's the theorem. So once again, redraw, label everything, do your define explore. We have a limited number of options on how to get sides congruent and how to get angles congruent. Those are the things you are looking for. Do I have bisectors, midpoints, perpendicular lines, parallel lines, vertical angles? Use all of that to your advantage, redraw, and you know my feelings on color. Color is good. I think you will do fabulous on these, and we are done with the first half of Chapter 4.